So measurements. So students should be able to identify and measure or calculate temperature. So we're going to focus on temperature in this lesson. So temperature, very briefly, is a measure of how hot or how cold an object is. Temperature is measured in degrees Celsius, and we also use another scale called the Kelvin scale. And generally, when we're measuring temperature, we measure temperature with a thermometer. Okay, so something that looks like this, or you can also have digital thermometers as well. Now, as I say, in some cases, we can use, instead of using the degrees Celsius scale, we can use this thing called the Kelvin scale. And the unit of temperature is measured in the Kelvin, and it has this letter K beside it. So 0 Kelvin is theoretically the coldest temperature possible. So this here, it compares the two temperatures together. Okay, so 0 Kelvin, if you were to put that in degrees Celsius, it would be minus 273.16 degrees Celsius. So very, very, very cold. If we take, for example, like a freezing cold day would be 0 degrees Celsius, that would be 273.16 Kelvin. And then if you were to take, like, let's say the next kind of reference point, if you were to boil a kettle and when the water starts to boil, boiling water is at 100 degrees. If you were to put that into Kelvin, it would be 373.16 Kelvin. So that's the kind of comparison between these two. So really the idea is you want to kind of think about, well, what exactly do we mean by like hotness or coldness of an object? What does that actually mean? So temperature is very much linked in with this idea of what's called kinetic energy. And kinetic energy is basically the energy an object has because of its motion. So for example, if I had, let's say, a particle like this, okay, the more this particle is vibrating or moving, the more kinetic energy it has. Okay, so kinetic energy is just the energy an object has because of its motion, okay, when it's in movement. And temperature is directly linked into that. So if we remember, okay, so the states of matter, you can have solids, liquids, gases, and then you can have these what are called plasmas. So you can think about everything around you. So everything around you has the potential to be like at different degrees of temperature, hot or cold. So the things around you are made up of particles, and those particles can be arranged as solids, liquids, or gases, or in the case there can also be plasmas as well in the environment around you, such as neon signs. So how do we link this then to temperature? Well, if you were to imagine the particles, okay, making up the object. So for example, this here might be the handle of a saucepan, for example, and you have all the individual atoms that make up that handle of a saucepan, and they're all kind of packed solidly together because they're a solid, so they're going to be packed structurally together like this. If I then start to apply heat, what will start to happen is each of these individual atoms will absorb some of that heat and they'll start to move and vibrate. Okay, and when they start to move and vibrate, they start to heat up and their temperature starts to rise. So what will happen then is they will go from this cold state to this hot state. But what's happening from a particle point of view that makes up the object that's getting hot? Well, the particles inside the object are starting to vibrate. Okay, so the more they vibrate, the more kinetic energy they have. So temperature is really a measure of, if you were to take all the atoms or all the particles that make up the object that you're measuring the temperature of, it's kind of calculating the average kinetic energy of all of the particles that make up that object. So the more the particles are vibrating, the hotter it is. And what will happen is heat energy, okay, it'll travel from a so it'll travel from a hot object to a cold object. So what that means is that if you have a hot object, the particles in it are vibrating an awful lot, and then if you touch that hot object to a cold object, the particles in the cold object will then start to vibrate, and so on and so forth. So it travels from a place of, so temperature or heat, it travels from hot to cold. Or sorry, from the other way around, should I say, from cold, yeah, so it'll travel from, so if you have, let's say, a hot object here, what will happen is that heat will travel from where it's hot into the regions where it's cold. Okay, so it spreads through, like let's say out here it'd be cold. And that's what happens. Okay, so this heat energy moves through the object from hot to cold. So really, when you're measuring temperature, you're measuring like how much the particles in the object are vibrating. The more they're vibrating, the hotter it is. The less they're vibrating, the colder that it is. And this links in then to states of matter as well. So for example, if you have a solid object, the particles in the solid object are packed together very tightly. If you apply heat to that, and if you apply enough heat, depending on the particular atoms that make up the object, what will happen is you will disrupt the solid structure so much that it will melt. Okay, so it'll turn into a liquid. So different amounts of heat, so you need different amounts of heat for different materials to turn from a solid into a liquid. But what essentially you're doing is you're taking the arrangement of particles that are in the solid, you're breaking them up, and you're making them more loosely connected together. Okay, so that's in a liquid. So in a liquid, the particles are not as rigidly tied together as in a solid, and they're able to move across each other, and it gives it the characteristics of liquid. If you keep adding heat, so what's going to happen is these individual particles will start to vibrate more and more and more and more, and what will happen is they will actually start to break away from each other. And when that happens, we have vaporization, okay, or you have liquid turning into a gas. And then if you want to apply even more and more heat, like in a neon sign, for example, you keep applying heat, what's going to actually start to happen is the individual atoms that make up these particles, they will break down into protons and electrons, and they'll turn into what's called plasma. And then the reverse happens then as well. So if you take a plasma and you take away the heat, what's going to happen is it'll turn into a gas. And then if you take that gas and you take away the heat, it will condense into a liquid. And then if you take away more of the heat and cool it down, it'll freeze into a solid. Okay, so basically matter interacts with heat energy in this way. So when you're thinking about temperature and when you're measuring temperature, that's what you're measuring. So when you apply heat to the bottom of the thermometer here, what's actually happening is you're causing the liquid in the thermometer, the particles, to vibrate. And when they vibrate, they expand or move away further from each other, and they rise up the tube. And when they rise up the tube, then we can measure how much or how far did they rise up the tube. And that's directly proportional to the amount of heat energy that's present in the object that you're measuring the heat for. So if we have a look at this here, for example, so we've taken the temperature at the start. Okay, so we can see here that the temperature is in degrees Celsius. We have this little symbol here at the top, that means degrees Celsius. So we can see here that we started off with 75, 76, 77. So we've roughly about 78 degrees Celsius. Okay, so that's the temperature that we started off with. I'll just push this up here a little bit. Okay, so we started off with roughly about 78 degrees Celsius. And what we can see then is that has moved up to 89 degrees Celsius. So what we can do then is we can measure the difference in temperature from the start until the end. So how many degrees did it move up? So we can see that it went up to 89 degrees. So if we put in 89 and we minus what it started off as, 78. So it's increased by 11 degrees. So the change in temperature from start to finish was 11 degrees. 11 degrees Celsius. So that's the change in temperature. So that is really what temperature is. It's important that you understand like what temperature is and how to measure it. So you measure it using a thermometer, and you can use one of these guys, or you can use the digital thermometers as well. And again, on your thermometer, you will have these graduations like this. And all you do is you look and you see how far has the liquid in the thermometer moved up, and you just read that off the thermometer, and that is measuring temperature. And then this kind of gives you an idea of what's happening in relation to like what is temperature. So temperature basically is how hot or cold an object is. And what does that mean? It means basically like how much vibration there is in the particles that make up the object. If there's a lot of vibration, like here, the particles are hot. If there's less vibration, the object is cold. And then again, the amount of heat energy can have a massive impact on the different states that matter can exist in. So I'll just move this over here. So you can have solids, liquids, gases, and you can have plasmas, and depending on how much energy you add, or the temperature, so different materials will be in different states of matter at different temperatures. So for example, if you're to take water, so at 0 degrees Celsius, it'll turn into a solid, into ice. At between 0 and let's say 99 degrees or 100 degrees, it'll be in the form of a liquid, and then above 100 degrees, it'll turn into a gas. Okay, and that's just one example. And all different materials are made up of different types of atoms or particles, and they will all exist in different states at different temperatures. Okay, so that is temperature, and that is how to measure temperature.